Generally, we talk about lines being in two-dimensional space. So we'll have a Cartesian plane, and we may graph a line, and we have a y-axis and an x-axis. Okay, but what happens when we want to graph a line in three-dimensional space? So consider if we have an axis going up and down. We'll go ahead and stick with that being the y-axis. We have an axis going horizontally left and right. That will be the x-axis. But what if we, and you'll have to imagine with me because I can't draw on my screen in three dimensions, but what will happen if we have another axis coming straight out of the screen? Okay, straight out of the screen, right at you, and then going back into the screen as well. Okay, so a third axis, and we're going to call that the z-axis. Okay, then we could have a line in three dimensions. Okay, so it could, and again, it would be really difficult to draw, but let's say we have a line going this way. Okay, let me graph a point. So let's say we have a point at maybe -2 on the x-axis and maybe at +3 on the y-axis, and then at, let's say, +4 on the z-axis. So it would be somewhere about right here, and maybe that's poorly drawn, and it's very, very difficult to see, but it would be an ordered triple instead of an ordered pair if we were going to write it down. So if we have a point over here on our normal axis, let's say this one, this point right here, this would be the point 2, -3, right? And 2 represents, oh, I'm sorry, that would be the point 3, -2. Let me try that again. The point 3, -2, and 3 represents the x, and -2 represents the y. Well, over here, if we want to represent this point as an ordered pair, we would need 3 coordinates. And so we would have -2 for the x coordinate, 3 for the y coordinate, and 4 for the z coordinate. And so it would not be an ordered pair, but an ordered triple, because it has 3 components. Okay, so this is just introducing you to maybe a little bit of different stuff in geometry. Instead of 2 dimensions, we're going to be dealing with 3 dimensions in this lesson. Okay, check this out. These are some different scenarios of what can happen when planes intersect. Okay, so when we have an equation in 3 dimensions, okay, like for example the equation 2x plus 3y minus 4z equals 5. Okay, that's an equation in 3 dimensions because it has an x, a y, and a z. We could talk about a system of 3 equations, and they represent planes, and what happens with each of those. So if we have 3 planes intersecting one another, notice we have plane 1, 2, and 3 in blue, red, and green. When they intersect, they could potentially intersect at a single point, okay? These two, blue and red, intersect at a line, and blue and green intersect at a line, and red and green intersect at a line, and all 3 of them intersect at a single point. So that's one option. Another option is where all of them intersect, all 3 intersect at the same line, okay? So one line intersection. We could have where all 3 planes are the exact plane, same plane. So if you graph each plane, you would get one plane on top of the other on top of the other, okay? And then some other things that could happen, we could have all 3 planes being parallel. They don't ever intersect each other, they're just parallel. We could have that they intersect each other, but 2 of them are parallel, and those 2 never intersect each other. And then the third plane does intersect both of the parallel planes. So each of the, let's say the blue and the green, they have a solution, and the red and the green have a solution, but the blue and the red don't ever intersect, they don't have a solution. Over here in F, we also have a situation with no solution, because the red and the green intersect, the blue and the red, and the green and the blue, but they don't intersect at the same place. So there's no solution for all three together. And then we could have a situation where two of the planes are the same. 1 and 2 are the same in this case. 3 is parallel to them, and so there's no solution here either. Okay, so we could either have a point as our solution, a line as our solution, the entire plane as our solution, or in the case of these 4 at the bottom, we could have no solution. Okay, so extra choices. So let's look at that. Just to reiterate the choices, if you're graphing, or if you're looking for the solution of a system of 3 equations in 3 variables, and I'll show you what that means in 1 second, you have these 4 choices as your answer. Either a point, a line, an entire plane, or no solution. Okay, no points in common. Okay, so here is an example of a system with 3 equations, and the 3 equations have 3 variables. And so notice that this matches up. Before we did a system of 2 equations with 2 variables. Here we have 3 variables and 3 equations. That's kind of a key point. If you have 3 variables, you need at least 3 equations. And if you have 4 variables, you need at least 4 equations. So the number of variables determines how many equations you know you have to have. Could we have extra equations? Possibly. That might be okay. But if you have fewer equations, if we have 3 variables and only 2 equations, we already know that we're not going to be able to solve this. Okay, so now how do we solve it? We can use a combination of elimination and substitution. Your graphing calculator will not be able to graph 3 variables. It can only graph in 2 dimensions, not in 3. So a graphing calculator, or graphing it, might just be more confusing than it's worth. But we're going to try to use some substitution and some elimination. I'll probably stick with elimination because that's my preference, but you feel free to use what you would like. We're going to have to choose how we want to add these equations together and subtract, add them and multiply so that we can start eliminating some variables. So I'm going to try to add the first 2 equations together. So if I add equation 1 and 2, plus z equals 2, x minus y plus 2z equals 2, I'll get a new equation, 2x plus 3z equals 4. Okay, so I've eliminated the y out of this equation. Now I'm also going to try to add another 2 equations together. So I've just added equation 1 and 2 together to get this new equation. I'm going to try to add another pair of equations to also eliminate y. Okay, so for example, I might try to multiply this first equation by 2. Okay, so 2, 2, 2, and this would now be 4. And I would, let's multiply by -2, make it negative. Then I'm going to add that equation, negative 2x minus 2y minus 2z equals negative 4. I'm going to add that to this last equation, 2y minus z equals 1. And the reason I decided to multiply this by -2 before I added it to equation 3 is so that I could again cancel out my y's. I'll have negative 3x minus 3z equals negative 3. Alright, so now I have 2 equations and neither of them have y in it. And the reason I would want to do that is so that I could then use those 2 equations, 2x plus 3z equals 4, and negative 3x minus 3z equals negative 3, to hopefully figure out one of my variables. I'm going to do elimination on these 2 new equations. The z's will cancel out. I will get negative x equals 1. So now I know a vital piece of information. I know that x is negative 1. Okay, and then you can start working your way back up the ladder. So we figured out that x equals negative 1. I'm going to plug that into this equation. Either one of these two equations would be fine. I'm choosing this one. So 2 times negative 1 plus 3z equals 4. So negative 2 plus 3z is 4. 3z is 6, and z is 2. All right, so we have another piece of information. Z is 2. Then we can use those two pieces of information. Here, let me erase a good space for us to work in. We can use the fact that x is minus 1 and z is 2 to figure out the last variable y. So I'm going to plug in 3 times negative 1 minus 5y plus 2 times 2 equals 1. I'm plugging this in to the first equation right here. Okay. That way I can figure out what y is. This will be negative 3 minus 5y plus 4 equals 1. Negative 5y plus 1 equals 1. Negative 5y equals 0. So y has to be 0. Now we have all three pieces. And this is our solution. You could write this as an order triple. So you can write it as negative 1, comma 0, comma 2. Okay. This point in three-dimensional space is the solution to this system of equations. Great. What happens if you have a system like this with an x and a y and a z, and an x and a z? So in essence, some terms are missing from each equation. Well, what that means is, in the case of the first one, you have x minus y plus 0z equals 6, because the z term is missing. So it's like 0 times z. What is 0 times z? It's just 0. And you can add 0 to anything and not change it. In the case of the second one, we have 0x plus 2y plus 5z equals 1. And in the case of the third one, you have 3x plus 0y minus 4z equals 8. Okay, so if you think about that in your head, it might help you. And from there, it's just a normal system of three variables to solve. Okay, so let's, why don't we add the first two? I'm looking at this. I think the first two might be a good choice to add. So if we add them right now, nothing will cancel out. But let's hope that the y's will cancel out. So what do we need to multiply this first equation by to get these y's to cancel out right here? 2, right? Okay, so let's multiply the first equation by 2. We will get 2x minus 2y plus 0z equals 12. And in the second equation, we'll leave it alone. 2y plus 5z equals 1. So when we add it, the y's will cancel out. We'll have 2x plus 5z equals 13. All right. And now what are we going to do? Okay, we could try to do another elimination step, right? Which two equations are we going to use for our elimination? Well, why don't we use these two? This one, 3x minus 4z equals 8. And this one, oh, I'm sorry, this should be a z right here. Because they both have an x and a z in them. So that way we can eliminate something without introducing anything else. Okay, so let's do these two equations, but we're going to go ahead and multiply by what? Okay, first we have to decide what we want to cancel out. Let's hope that the x's will cancel out. Okay, so I'm going to multiply the first equation by -2. So this will be, for multiplying this one by -2, we'll have -6x plus 8z equals -16. And we'll multiply this one by +3, and hopefully it'll cancel out. So we have 6x plus 15z equals 39. Alright, when we add them, the x's will cancel. Great. And then we have 23z equals 23. That's pretty convenient. Divide by 23 on both sides. Z is 1. So that's the first piece in solving this equation. Then we can plug in z into whichever equations we want. Probably not the first one, right? There's no z spaces, but we could plug it in here or here or here. We have lots of choices. Let's go ahead and plug it into equation number 2. 2y plus 5 times 1 is just 5 equals 1. So 2y equals -4 and y equals -2. So we have our second piece. Let's go ahead and find the third piece. I'm going to plug in z equals 1 into equation number 3. So we get 3x minus 4 times 1 is just 4 equals 8. 3x equals 12 and x equals 4. So we have z, we have y, and we have x. We could write our answer as a triple, an ordered triple. X first, then y, and then z. Awesome.